Hello and welcome to lesson 3.3. Today we're going to look at solving equations that's going to have variables on both sides of the equal sign. So to see how this works, let's look at example 1. It says you can buy used inline skates from your friend for $40 or you can rent some. Either way, you must rent safety equipment. How many hours must you skate for the cost of renting and buying skates to be the same? So what you need to do is you need to find out what your cost is to buy skates. So to buy skates, it tells us that we're going to spend $40 to buy our friend's skates, plus we have to rent our safety equipment. Well, our safety equipment rental, we can see down here, is $1.50 per hour. So because I see this per hour right here, that typically tells me I'm going to be multiplying that $1.50 by the number of hours I work. So I'm going to add this 1.5 and I'm going to multiply that by H. Likewise, if I rent skates, so if I'm going to rent skates, it tells me right here that I'm going to be spending $3.50 per hour to rent skates. And because again, I have that per hour rate, I'm going to put an H there. So this $3.50 is going to take into account probably my safety equipment and, oh yeah, you can see right here, it says inline skates and safety equipment. Okay, so now my problem says, how many hours must you skate for the cost of renting and buying skates to be the same? So if I want to know when the two things are going to be the same, I'm literally going to set the equations equal to one another. So I have 40 plus 1.5h equals 3.5h. And now what I have to do is I have to solve for h. In order to do that, you need to get all of your variables on one side. So in this example, what I'm going to do is I'm going to subtract 1.5h from both sides, so that all of my h's will be on the right. When I do that, I'm left with 40 on the left equals 3.5 minus 1.5h is going to give me 2h. And then now I can go ahead and solve for h by dividing both sides by 2, so I can get that h by itself. My 2's are going to cancel, and I'm going to be left with h equals 20 hours. So that means in order for my cost to be the same to rent or buy the skates and then rent the equipment, I would have to skate for at least 20 hours. Example 2 says a hairdresser is considering ordering a certain shampoo, and she has two different companies. Company A charges $4 per 8-ounce bottle plus a $10 handling fee. Company B charges $3 per 8-ounce bottle plus $25 handling fees. How many bottles must the hairdresser buy to justify using Company B? So what we need to do is we need to figure out what the cost of Company A is. So it tells me that we have 4-ounce bottles plus a $10 handling fee. So you're going to pay that $10 handling fee regardless of how many bottles you buy. So I'm going to add that $10 to my $4 per 8-ounce bottle. So I'm going to set this up as 4 times B, B being the number of bottles that we purchase. Company B says we have $3 for every 8-ounce bottle, but it's going to be a $25 handling fee. So I'm going to spend $25 regardless of the number of bottles we buy, and then it's $3 for each bottle thereafter. So now I have the two equations that I need to figure this out. So what I'm going to do is I'm going to set them equal to one another to find out when my break-even point is. So here I have 10 plus 4b equals 25 plus 3b. And again, I want to get my variables all on one side. So right away, I'm going to subtract 3b from both sides, just because the math is going to work out nicer. So by doing that, my b's cancel off the right, and I'm left with 25 on that side. On the left, I still have 10 plus, then I have 4b minus 3b is going to leave me with just b. I still need to get b by itself. So to do this, I am going to subtract the 10. And now my 10s go away, leaving me with just b on the left. And 25 minus 10 is going to give me 15. So what this tells me is I need to order at least 15 bottles. So you need at least 15 bottles in order for company B to be a better deal. At 15 bottles, they're break even, or they're going to cost you the same. But once you purchase that 16th bottle or more, then company B is a better deal. Example 3 says, a Shoppers Discount Club charges a monthly fee of $15 and sells gasoline for $2.05 a gallon. And the station across the street sells their gas for $2.35 a gallon, but they have no fees. So how many gallons of gasoline would you have to buy in 1 month to spend the same amount at either store? So again, we're looking for that break-even point. So I'm going to put our discount club, which is the first gas station. We're going to find out their cost, and we can see that you're going to spend $15 plus $2.05 per gallon. And again, I have that word per, so that means I'm going to have 2.05, and I'm going to use G for gallon. And then I'm going to put the other station. Now they don't have like a club fee. Their gas though is just a little bit more money. So here it says it's $2.35 per, which means again multiply, or actually it means divide, but we're going to have to multiply by our variable. So this is 2.35 times the number of gallons. So I'm going to set them equal to one another. So here I have 15 plus 2.05 G equals 2.35 G. And now I'm going to solve for G. Here I'm going to subtract 2.05 G, and I like to subtract this because on this side of the equation I've only got one number and it's the only one with my variable. So I'm going to subtract 2.05 G from both sides. This is going to give me 15 on the left equals 235 minus 2.05 is going to give me 30 cents or 0.30 G. And now if I go ahead and simplify, I have to divide both sides by 0.3 in order to get my G's to cancel, or my G by itself. So here I'm left with G on the right, and 15 divided by 0.3 is going to be 50. So what this tells me is we have to purchase 50 gallons of gasoline for the two stations to have the same price. Example 4 says Texas Instruments manufactures graphing calculators. They spend $150,000 per day in overhead expenses. It costs them $50 to make each calculator. The calculator sells $125 each. Write and solve an equation to find how many calculators they must sell for their costs to equal their revenue. So this is kind of like a classic business case. So you want your cost to equal your revenue. This is what we call our break-even point. This is where the company's not making money, but it's also not costing them to produce anything either. So for our costs, okay, it says that they spend $150,000 per day in overhead expenses. And then it says it's $50 to make each calculator. So they have $150,000 plus $50 for each calculator. So I'm just going to go plus 50x because we don't know how many calculators they're producing. Now revenue is the amount of money that they are bringing in. So when they sell something, that's the money that they're bringing in, or their revenue. So they are selling them for $125 a piece. And again, we're going to multiply this by x because I need to take that 125 and multiply it by the number of calculators that they're selling. So now I need to find out when my cost equals my revenue. So I'm going to set my two equations equal to one another. So we have 150,000 plus 50x equals 125x. In this case, I'm going to start out by subtracting my 50x from both sides. When I do that, we end up with, let's see if we can slide this up. I have 150,000 left on this side. These are going to cancel. And 125 minus 50 will give me 75x. And now if I divide both sides by 75 so that I can get x by itself, we end up with x being equal to 2,000 calculators. Okay, so that means they have to sell 2,000 calculators just to make, just to break even. Now for example 5, we're told to find the value of x in the diagram below. So we have two lines, okay, and I don't know if you've seen this before, but usually when you have what we call vertical angles, notice this angle here is vertical, okay, or right across from this angle here. So these two angles are known to be the same or equal to one another. So when I'm given a diagram like this, if I have to solve for x, all I have to do is set the two equations equal to each other. So I have 5x minus 3 equals 2x plus 12. And then now I'm just going to go about solving it like I would any other algebraic equation. So if I subtract 2x from both sides, this is going to give me 3x minus 3 equals, these are going to cancel, and I'm left with 12 over there. I need to get x by itself, so I'm going to undo my subtracting 3 by adding 3 to both sides. Now I'm left with 3x equals 15, and again I need to get x by itself, so I will divide by 3, and I'm left with x equals 5. Now every once in a while we run into a couple special cases when we're solving equations, okay? Sometimes we'll run into an equation that has no solution, and we know it has no solution because the value of the variable makes the equation not true. Okay, so an example of this is 2x equals 2x plus 1. If we go and try to solve this one, and I were to subtract 2x from both sides, notice we're going to end up with 0 equals 1. This is not a true statement. So because it's not true, this tells me that I have no solution. Okay, 0 does not equal 1. So you could even go in and say does not equal 1, therefore it's not true. Okay, now for the second scenario, we have what we call an identity. This means that every value that we plug in for x, or the variable, is going to work and be true. And here we get that because I have 2x equals 2x, so first and foremost you can see that they're the same. Sometimes it's not this straightforward though. If I were to go and I were to try to subtract 2x from both sides, okay, you end up with 0 equals 0. This is a true statement. You do get the exact same thing on both sides. So this right here tells us that we have infinitely many solutions And why we say it's infinitely many solutions, because there is no, like any value that I can think of to plug in for x will work and make these two equations equal. So we are going to end on this note. Please let me know if you have any questions. Otherwise, I hope you have a great day and we'll see you in class.